So using the language of Venn diagrams, we can define a probability. Let's say out of some total set of all possible events, which I'm going to call as a set S. Maybe we're interested in some particular subset of events that I'm going to call H. And so we would define the probability of H as basically being the size of, and for the moment we've just completely intuitive what we mean by size of the set that is basically the intersection of our subset H out of the total set of events that we're considering as all possible events S, divided by the size of the total set of all possible events. Okay? It's just the intuitive definition of probability. So I'm going to call that unconditional probability, and that we're not placing any conditions on this, at least not explicitly. In other words, there's no condition in that probability. This is sometimes referred to as marginal probability. Now we can toss another variable into the mix. Let's call that another subset of events that I'm going to call O. And in this particular case, it overlaps H. This is a non-empty intersection between those two subsets. So we would call the probability that both event H happens and event O happens. And I'm going to use set intersection for the moment here as my AND operator. So intuitively, that would just be sort of size of the intersection of H and O out of our total set of all possible events divided by the size set of all possible events. Again, just intuitive definition of probability. Question?
Should the blue only be there in the intersection?
I'm just coloring H blue just to have it be H. Sorry. I could have made O another color and then you'd see like the overlapping colors or something, but I didn't do that. Sorry. So now we can also use the same kind of intuitive idea to define conditional probability. So now we would say that the probability of H given O, so now we're talking about, for example, the probability that event H happens given that event O definitely does occur. We'll write that as P of H, and then this vertical bar, usually read as given O, would now be, again, just this intersection in the numerator. But now in our denominator, we're not taking the set of all possible events, but we're just taking the set of events actually that are in our condition. So here I'm being explicit that all this is within our total set of all possible events S, so I'm writing this as O intersect S. Okay?